Jai to all. Today I am here to present the lecture on topic jet transform, and the subject is signal system KEC 403, and I am Dr. Amit Garg, Associate Professor in EC Department of AKGEC. So in this particular lecture, we will discuss the various aspects of jet transform, like why jet transform is used, and how can we apply jet transform to find out the signal analysis in jet domain. Jet domain is basically your complex domain. Okay, so let us start. First of all, jet transform is the discrete time counterpart of the Laplace transform. Means you have already gone through Laplace transform. You have already gone through Laplace transform. So Laplace transform is basically for continuous time systems. Means for the analysis of continuous time signals and systems, basically we use Laplace transform. Okay, so like Laplace transform is used as an extension of continuous time Fourier transform. Our jet transform is also the extension of you can say discrete time Fourier transform. Okay, so you can say we are having transforms like continuous time Fourier transform, discrete time Fourier transform, then DFT, then Laplace transform, then jet transform. So your Laplace transform is applicable basically for continuous time signals, and jet transform is for discrete time systems. The jet transform introduced to represent discrete time signals in the jet domain. So jet is you can say a complex variable, which we will see it like z is equal to r e to the power j omega. Okay, so you can say this is a complex domain, and jet transform is the extension of DTFT, which enables us to analyze certain discrete time signals that do not have a DTFT. Means the issue with the DTFT is that we will not be able to apply discrete time Fourier transform on the signals which are not absolutely summable. Means for applying DTFT, your system should be stable. Only in that case you can apply DTFT. Okay. So for those cases, for the analysis in frequency domain, we generally use this jet transform. Okay. Again, like Laplace transform, jet transform comes into two varieties, like bilateral or two-sided jet transform, or you can say unilateral or one-sided jet transform. Okay. Similarly, we have seen this in the case of Laplace transform. Now, bilateral Laplace transform is generally used for finding out the nature of the system characteristics such as stability, causality, and frequency response. So, stability, causality, and frequency response of an LTI system can be obtained using bilinear Laplace transform. Similarly, unilateral Laplace transform is a convenient tool for solving differential equations with initial conditions, which means you can find out the transfer function of a system that can be applied over a difference equation to obtain basically the transfer function of the system. Okay. Now, next slide we will see. So, so jet transform of a general discrete time signal Xn is defined as this is the expression for bilateral jet transform. You can see limit is from n equals to minus infinity to infinity xn into z to the power minus n. And similarly for unilateral jet transform, because we are taking only one-sided jet transform, so this is n equals to 0 to infinity xn into z to the power minus n. We will not take value from minus infinity to 0 in this case. Okay. So where z is a complex variable, we have already discussed this z. So z will be equal to r e to the power j omega. Okay, where r is basically the radius of a circle, and omega is basically circle radius, and omega is basically the angle from positive real axis. Okay, this we will see later on also. So relationship between xn and its jet transform is indicated as, so this is the general way of expressing jet transform. Xn, like this is the symbol you can use. Okay. Now we will see jet plane. So because after applying jet transform on a signal, we will get the information in the jet plane, So this is basically the unit circle. So you can say this radius is mod z, that will be equal to 1, and omega is the angle made from the positive real axis. Okay, and here you can assume that there will be any pole or anything. So by increasing the value of omega, you can cover the entire circle, or you can cover the entire circle. And also, if the radius changes, then the value of radius of the circle will become changed, and you are having circles of different radiuses. Okay. So it is convenient to express the complex number z as a location in complex plane term the z plane. Point z equals to r e to the power j omega. This we have already discussed. It is in polar form. Is located at a distance r from the origin and at an angle omega from the positive real axis. So what is r? R is basically the magnitude of z, and w as the angle of z. Okay. Now in terms of r and w, equation of z transform become, now we will put in place of z, we will put z equals to r e to the power j omega. So you can see the expression will now become xn into r e to the power j omega to the power minus n. Okay. So this can also be written as summation n equals to minus infinity to infinity xn into r to the power minus n into e to the power minus j omega. So what is this? If you will see closely, then this is the expression of dtft. This is the expression of dtft of the sequence xn into r to the power minus 1, r to the power minus n. So you can say z transform is nothing but the dtft of the sequence xn into r to the power minus n, where r is the radius, and this r to the power minus term will be decaying factor, or it may be growing factor with increasing n, depending upon the value of n, depending upon the value of r, whether r is greater than or less than unity. So if it is greater than r, then you can say it will be decaying, and when r is less than 1, then it is growing. Okay. And for r equals to 1, you can take the mod z equals to r e to the power j omega as, now if you are taking the mod, so mod z will become mod of r e to the power j omega. So mod z will be equal to mod r, mod of e to the power j omega, and mod of e to the power j omega is under root cos square omega plus sin square omega. That will become 1. Okay, because you will e to the power j omega, you will write as mod of cos omega plus j sin omega, then you will take solve it, and you will get 1. So you can say mod z equals to mod r, and in our case r we are taking as 1. So for r equals to 1, or you can say mod z equals to 1, you can see here this equation reduces to the dtft, that is xz at z equals to e to the power j omega, because r value is 1 we are taking. So this will become x e to the power j omega, and you can say this is nothing but the Fourier transform of the signal xn. Okay. So you can say z transform reduces to dtft when the magnitude of the transform variable z is unity, that is for z equals to e to the power j omega. So you can say if the signal that we are taking is stable, if the system that you are taking is stable, then if you will simply put z equals to e to the power j omega in the expression of xz, then you will get the corresponding dtft value. Okay. So you can also get the dtft value from here also. Now region of convergence of z transform. So this is the important one. Since the z transform is an infinite power series, you have seen that we are taking summation from minus infinity to infinity. So it exists only for those values of z for which the series converges. So we have to find out those values of z for which the series converges. The range of values of mod z equals to r for which the z transform converges is termed the region of convergence. So we have to find out the range of values of mod z equals to r for which the z transform converges is termed the region of convergence, or ROC. Or you can say if z transform converges, it means it will attains finite value. Okay. So that is ROC consists of those values of R for which the DTFT of xn into R to the power minus n converges, or you can say ROC consists of those values of R for which you can say for which you can say, if you will say this in terms of Z transform, then you can say where this xn converges. Okay. Now, by limiting ourselves to a certain range of values of R, we may ensure that xn into R to the power minus n is absolutely summable, even though xn is not absolutely summable by itself. Means, let us suppose you have given a signal for which you cannot apply DTFT because that signal is not absolutely summable. So what you can say, what you can do now, if you are taking the signal xn into R to the power minus n, then it is possible that for a specific range of R values, that signal will now become absolute summable, which was previously not absolute summable. So if it is absolute summable now then you can apply now you can obtain the Fourier transform for that signal also. Okay. So the ROC can also provide us with information about whether xn is Fourier transformable or not. So this we will see how from the xn we will get the information that how our signal is Fourier transformable or not. In case of DTFT, the ROC is a circle of radius 1, that is unit circle, and x to the power j omega can be obtained by replacing z in xz by e to the power j omega. So if we came to know that the signal for which we are applying Z transform or for which we are calculating Z transform, overlaps the circle of unit radius, If it is so, then that signal is also Fourier transformable. Okay, so what we have to do? We will calculate Z transform and simply put Z equals to e to the power j omega in the equation to get the DTFT for that signal. Now, ROC for the following types of signals are discussed here: infinite duration, right-sided or causal signal; infinite duration, left-sided or anti-causal signal; infinite duration, two-sided signal or non-causal signal; finite duration, right-sided or causal signal; finite duration, left-sided or anti-causal signal; and finite duration, two-sided or non-causal signal. Okay. So now, first case we will see. Case 1, infinite duration, right-sided causal signal. Okay. So let us suppose we are taking a sequence xn that will be equal to R1 to the power n, where n is greater than equal to 0. Okay. So now we will apply Z transform over this sequence xn. So the definition of Z transform, according to the definition of Z transform, we will write it like this. And then because we are dealing with right-sided signal or causal signals, so now because it is defined only for n greater than equal to 0, so the limit will be from 0 to infinity. Summation limit will be from 0 to infinity, and R1 to the power n, Z to the power minus n. Now you can write it like R1 Z to the power minus 1 whole power n. Okay. Now for this is the series. This is the infinite series where lower limit is 0 and upper limit is infinity. So this series converges when this series converges. This series converges when R1 Z to the power minus 1 should be less than 1. If it is so, only then this series will converge. If R1 Z to the power minus 1 will be greater than n, greater than 1, in that case this series will not converge. Okay. So that's why the value of R1 Z to the power minus 1 will be like this. It will be greater than 0 and less than 1. And mod we are taking because we are working with this circle. So all the values will become same, plus or minus in this case. Okay. So summation n equals to 0 to infinity R1 Z to the power minus 1 to the power n. Now we are applying infinite series formula. So that will become first term, that will become 1 upon 1 minus the common ratio, that is R1 Z to the power minus 1. Okay. So therefore xz will become this, and now if you will manipulate it or multiply simply by z, then we will get z upon z minus R1. Okay. So the condition for the convergence of xz is mod of R1 Z to the power minus 1 is lying between 0 and 1. From here, or you can say mod of R1 Z to the power minus 1 should be less than 1, and from here we can see the condition for ROC in this case will be mod Z is greater than mod of R1. Okay, mod of R1. So this is the condition. So you can say ROC of XZ is to the exterior of the circle of radius R1 in Z plane. So you can see the ROC. We have drawn ROC here. Here there is a circle of radius R1 and this is the ROC. So for right-sided infinite duration right-sided signal, you can see the ROC is right. Or outward to the circle of radius R1. Okay. Similarly, if we'll see the case of infinite duration left-sided signal or anti-causal signal, here let us suppose we are taking another sequence R2 the power n and we are assuming the values n are less than equal to 0. Okay. So in this case, what happened? Now the transform of xn is, you can write it xn z to the power minus n. This is the definition. Now, because this n is less than equal to 0, so the limit will become summation n equals to minus infinity to 0 and r to the power n z to the power minus n. Now we are changing the limit, so n will become minus n. So this is r to the power minus n z to the power n, and you can see the limit will become changed. It is 0 and it will become infinity. Okay. So this you can write as r to the power minus 1 z to the power n. Now for convergence of this series, again for the convergence of this series, infinite series, this R2 to the power minus 1 z should be less than 1. Okay. So this is the condition we have taken here. Okay. And the solution is 1 upon 1 minus r to the power minus 1 z. So xz, if you will see here, you will get minus r2 upon z minus r2. Okay. Now if you will see the ROC condition here, this R2 inverse z should be less than 1 and you can say mod z is less than mod of R2. It means ROC of xz is to the interior of the circle of radius R2 in Z plane. So this is the circle and this is the R2 radius circle and ROC is inside this circle. Okay. Or you can say for anti-causal signal, the ROC is you can say inside the radius of the circle. Okay. Then infinite duration two-sided signal. Let us suppose we have taken another signal which you can say a non-causal signal. Okay. Because un and u of minus and minus 1 both are there. Okay. So we will apply Z transform over it. So we can write limits from minus infinity to minus 1 and for this the term is r to the power n z to the power minus 1 z to the power minus n, and for this r1 to the power n z to the power minus n 0 to infinity. Okay. Again, now what we are doing, we are changing the limit here. So n will be replaced by minus n. So we will get this and n equals to 0 to infinity. This term will be as it is. Now here the limit is from 1 to infinity and we want to apply infinite series formula. So we will make it 0. So at n equals to 0, the value will become 1. So we will reduce minus 1 from this and put the limit from 0 to infinity. And ultimately when we have solved it, okay, so when we have solved it, so for the convergence of this term, again this term should be less than 1 and for convergence again this term should be less than 1. Okay. So first of all, this R2 inverse Z to the power n converges if this R2 inverse Z is less than 1. This is the condition we have already seen. So from here we will get the condition mod Z is less than mod of R2. And for second term, you can see this is the second term, and here in this case ROC is, you can say R1 Z to the power minus 1 n. So it will be converges only when R1 Z to the power minus 1 converges. Okay. So here we have taken this value less than 1 and here from here we will get mod Z is greater than R1. So overall ROC of xz is to the region between two circles of radius R1 and R2 in the Z plane. So here you can see that the ROC is mod of R1 is less R1, mod Z is between mod of R1 and mod of R2. So you can see this is the inner circle and this is the outer circle, and the ROC is this shaded area. Okay. So ROC is this shaded area. Another important thing is that here for anti-causal signal, the radius R2 is less than the radius, radius R2 is greater than the radius R1. If the condition is different, means if R1 will be greater than R2, then in that case, you will not get this overlap area, but you will find that there will be no overlap, and so in that case there will be no jet transform exist. Okay. Now case 4, this is for finite duration signal, causal signal. So let us suppose we are having a sequence xn that can be represented in x0, x1, x2. These are the elements of our sequence, and simply because n elements are there, so we are putting the limit n equals to 0 to n minus 1, xn into z to the power minus 1 n. Then we will solve it, and in general sense you will get this type of expression. So you can see now you have to find out the ROC of xz. What is the ROC of xz? You will see if z will become 0, then what will become? This term will become infinity, and if this term will become infinity, then your xz will become infinity and it will not converge. So ROC is the entire z plane except z equals to 0, because if you will put z equals to 0 in it, then it will become infinity. So ROC is entire z plane except z equals to 0. You can see this from this question. Here one of the sequence is given 1, 2, 4, 7. So if we will apply this formula, then we will get 1 plus 2 z to the power minus 1 plus 4 z to the power minus 2 plus 7 z to the power minus 3. Okay. So by this, now you can see if you will put z equals to 0 here, then the value will become infinity. So your ROC cannot be, ROC will be the entire z plane except z equals to 0. Okay. And you can see this is the, and this is z equals to 0. You can say this is excluded from this ROC. Okay. Now finite duration left sided or anti-causal signal. Again, the same formula will be there, but this time we will move from minus n minus 1 to 0, xn z to the power minus n. And here we will see, if we will see here, then we are having the positive powers of z. Okay, so if we are having the positive powers of z and z will become infinity. Okay, so sorry, positive powers of n. So if z will become infinity, so at n will become infinity, you can say the value will become infinity. So entire z plane except z equals to infinity. You can see this from this question. If you will solve this, this is a anti-causal signal. So this is corresponding to 7 plus 4 z to the power 4z plus 2z square plus 7 plus 1 into z cube. Now, if in this equation you will put z equals to infinity, okay, if you will put z equals to infinity, then what happened? This will become infinity, and so ROC cannot be, ROC is the entire z plane except z equals to infinity point. Okay, so this is the ROC. And sixth one is the finite duration two-sided or non-causal signal. So here you can say non-causal signal which lies in both left region and also in right region. So if you want to represent it, then this may be the formula, x n equals to minus m to m x n z to the power minus n. And finally, if you will get this type of expression. So important thing is that here you will find that you will get the positive powers of z as well as negative powers of z. So either z equals to 0 or z equals to infinity, either z equals to 0 or z equals to infinity value, you will get xz equals to infinity. So ROC is the entire z plane except z equals to 0 and z equals to infinity. So this is one of the example I have taken 1, 2, 4, 7. So if you will write this is corresponding to z, this is 2, z plus 2 plus 4 z to the power minus 1 plus 7 z to the power minus 2. Okay. And ROC is what? You can see if you will put z equals to 0 in it. So if you will put z equals to 0 in it, and you can see that at z equals to infinity, this will become, if you will put z equals to 0 in it, so 4 by z, which means this term will become infinity, so overall xz will become infinity. And for z equals to infinity, you will put it over here, so this xz will become infinity. Okay. Now we will see the properties of ROC. So ROC of xz consists of a ring in the z plane centered about the origin. If xz is rational, then ROC must not contain any pole. So important thing is that ROC will not consist any poles. Okay. So that's why wherever poles occur, ROC will be starting from here, but we will represent it by dotted lines. Okay. So here we have seen that if xn is right sided and of infinite duration, then the ROC is the region in the z plane outside the outermost pole. So if more than one poles are there, then if our signal is right-sided signal, then in that case the outermost pole, the ROC will be outside the outermost pole. And in this case, if it is infinite duration signal, then it will include Z equals to infinity also. If Xn is a left-sided signal and of infinite duration sequence, the ROC is the region in the Z plane inside the innermost pole. Okay. So inside the innermost pole, ROC will be there. So it will definitely include Z equals to 0. And if Xn is of two-sided and of infinite duration, then the ROC will consist of a ring in the Z plane. Ring in the Z plane means due to one region that will become outward, and from one that will become inward. So you will get, for a finite duration right-sided signal, the ROC will be the entire Z plane except Z equals to 0. For a finite duration left-sided signal, the ROC will be the entire Z plane except Z equals to infinity. And for two-sided signal, we have already seen Z plane is except Z equals to 0 and Z equals to infinity. Okay. Now these are the properties of Z transform. Linearity property will be there. So you can see these properties. X of time reversal property, X of minus n will become X of Z inverse, and time shifting property, X of n minus k means we are shifting the signal by k units in time in right direction, then we have to multiply by Z to the power minus k in frequency domain or in Z domain, and X n plus k means we are advancing the signal by k unit in time. So what we have to multiply, Z to the power k we have to multiply, and it will become Z to the power k xz. Now convolution property, convolution of two sequences in time domain corresponds to multiplication in frequency domain of multiplication of Z transforms in frequency domain or in Z domain. So what you will do, if you have to do the convolution x1n convolution x2n, then what you can do, you will take the Z transform of individual signal and you will simply multiply it, and after multiplication that you will get, if you again want to move into the time domain, then you will take the inverse Z transform for that. Now correlation Rx1 x2l, this is the expression for correlation, and you can see here this is basically the multiplication of x1z and x2z to the power minus 1, means you will take signal x1z and x2 1 by z, and then you will get the so this is your correlation property. Scaling property, a to the power n xn is x a inverse z. Okay, so if you want to find out, if you have to calculate the value of a to the power n xn, where a is the scaling factor, then it will become x a inverse z. N xn, so this is the popular formula of differentiation of Z transform, that will become minus z dxz by dz. Time differentiation, time differentiation, here time difference is there, so xn minus x of n minus 1. So if you will take the Z transform, then it will become xz minus z to the power minus 1 xz. How? From the time shifting property. So you can write it like 1 minus z to the power minus 1 xz. Then initial value theorem will be there. Initial value theorem, limit xn for n tends to 0, this will become limit xz mod z tends to infinity. Okay, so if you want to calculate the initial value, then from initial value theorem we can easily find it if we have given the Z transform value. Okay, and final value theorem, limit n tends to infinity xn. Okay, so this can be written like limit mod z tends to 1, z minus 1 upon z, or in another way we can write it like limit mod z tends to 1 minus z to the power minus 1 xz. Okay, so this is another way by which you can write it. But important thing for applying final value theorem is that final value theorem can only be applicable when poles of 1 minus z to the power minus 1 xz must lie within unit circle. So if the poles of 1 minus z to the power minus 1 xz lies within the unit circle, only then you can apply the final value theorem for finding out the final value of the signal in Z domain. If it is not so, then you cannot apply final value theorem for finding out the final value of the signal. But it doesn't mean that we will not be able to find out the final value of the signal, but it means that by this method we will not be able to find out the final value of the signal. Okay. So now this is simple example so I am taking the Z transform here. So a to the power n un is 1 upon 1 minus a z inverse. So you can write it like 1 upon 1 minus 0.5 z to the power minus n, and this is for anti-causal signal. So in case of anti-causal signal, this will become you will get minus sign here, and 1 upon 1 minus 0.8 z to the power minus 1. Okay, and if you will solve it, then finally you will get like you will take 0.5 z to the power minus 1, 1 minus 0.8 z to the power minus 1, and here you will get 1 1 cancel, and 1 minus 0.8 z to the power minus 1 plus 0.5 z to the power minus 1. So finally you will get at this point. Okay. So here in this case ROC, what is the ROC? Poles are at 0.5 and 0.8. Okay. So you can see this is the pole at 0.5 and this is pole at 0.8. Okay. And for this ROC is outside. Okay. And for this one, ROC is inside, means you can see this one. Okay. So what is the overlap region? Overlap region is between 0.5 and 0.8. So ROC mod Z is between 0.5 and 0.8. Okay. So this is basically the ROC. Okay. Okay. So because of time limitation, I am ending this lecture now. Thank you so much.